Okay, so we're still doing chapter 15. It's a different day, but that's all right. You don't know the difference. And we're going to do problems out of the textbook some more. And we're on page 363 of the textbook, and we're looking at number 11. And number 11 reads, and since you're reading along from the book, I don't have to put all this up there. Number 11 says, health. The probabilities that an adult American man has high blood pressure and or high cholesterol are shown in the table. Look at table with high blood pressure being across the top and cholesterol being across the left-hand side. A, what's the probability that a man has both conditions? Now, as we think about this, the probability that a man has both conditions would be the probability the man has high blood pressure and has high cholesterol. And as we think about it, we said, okay, if we see the word and, the very first thing we need to ask ourselves, how many events do we have here? And we are selecting a man at random. So and here means the intersection of both of these groups, or in this situation, the intersection of the column of high blood pressure and the row of high cholesterol. And since they're not giving you totals, the answer here simply is, where's that intersection take place? Well, it takes place at that 11%. Now, and also means multiply. Specifically, if you have more than one event, and means multiply. But and also means multiply if these events are independent. Do I know these events are independent? No. So I'm not going to multiply the probability of high blood pressure and high cholesterol because I don't know that they're independent. So I can't necessarily multiply. I'm just going to look for the intersection of those two groups. There's my answer, 0.11. All right, B. What's the probability that he has high blood pressure? Okay, so if he's got high blood pressure, we're talking about the probability of high blood pressure. What that actually means, because there's two conditions listed there under the high blood pressure column there, is that he could have high blood pressure and he could have high cholesterol, or he could have high blood pressure and okay cholesterol. And what's not given in the table, again, are those totals. And when we're talking about high blood pressure, we're talking about the probability that he has high blood pressure, which would be the total of high blood pressure. So what I could do is I could add those two values together, the high blood pressure and high cholesterol, or the high blood pressure and okay cholesterol, and 0.11 plus 0.16 is going to be 0.27. So this is 0.27. Okay, relatively easy. C, what's the probability the man with high blood pressure has high cholesterol? Okay, with high blood pressure has high cholesterol. What this is saying is, what's the probability that given the man has high blood pressure? I know he's got high blood pressure. So it's given that he has high blood pressure. What's the probability that he has high cholesterol? Now, what I'm doing here is, realistically, I am redefining the population as those people that have high blood pressure. What's those people that have high blood pressure? Oh, I found that out. That's the total of the high blood pressure column. That's 0.27. So that's 0.27. Of those people that have high blood pressure, that 0.27 column, how many people have high cholesterol? That would be those people that have high cholesterol and high blood pressure, 0.11. So 0.11 over 0.27 is equal to, and I did this calculation already, and we'll look at it. Ah, it's not here. I have to turn the page. This always happens. This is so sad. Oh, there it is. It's 0.4074. And again, it's 0.4074, and we're going to 4 decimal places. And the reason we're going to 4 decimal places is because probability is going to be listed as 4 decimal places, because in the Z table, probability is listed as 4 decimal places. So we're going to go probability is 4 decimal places, 0.4074. All right, D. What's the probability that a man has high blood pressure if it is known that he has high cholesterol? So we'll scroll down here because we've got a little bit of room left. What's the probability that he has high blood pressure if it is known that he has high cholesterol? Okay, so what I need to do is I need to know the population of people with high cholesterol. And that would be the high column, or the high row in cholesterol, which would be the 0.11 and the 0.21. So this value is 0.32. Of that 32% that have high cholesterol, how many have high blood pressure? That would be 0.11. So it's 0.11 divided by 0.32. dividing and taking that to 4 decimal places, that is 0.3438. There you go, number 11. Relatively easy. About as easy as you can get. 17. Cards. You are dealt a hand of 3 cards, one at a time. Find the probability of each of the following. Okay. So, you have 3 events happening here because you've got 3 cards one time and it does not say anything about with replacement. So that means that the probability is going to change from card to card to card. So be aware of that. What's the probability that the first heart you get is the 3rd card you're dealt? I didn't want this here. Let's insert new page before current page. There we go. All right. So what's the probability that the first heart you're dealt is? Let me try it again. What's the probability that the first heart you get is the 3rd card you're dealt? Okay. So as we're looking at this, because it can be confusing as you read it like that, what we said is take it event by event by event. All right. So what happens with the first card? So you've got 3 cards. It is not a heart. And the second card is not a heart. And the 3rd card is, oh, it's a heart. Okay, so what's the probabilities? First card is completely independent, not a heart. There are 39 not hearts out of 52 cards. Second card is not a heart. Now, the probability has changed because this is the probability of not a heart given that you've gotten not a heart. But what we're just going to say is its probability is not a heart knowing that it's changed because we're using our common sense here. And that is 38 over 51. And the probability that the 3rd card is then a heart, there are 13 hearts still left out of 50. You can multiply and you can get that answer. B, your cards are all red. Okay, so probability of red and red and red. Again, without replacement, so we're talking about conditional distributions here. So, probability the first card is red is 26 out of 52. Probability the second card is red. Probability has changed. There are 25 red cards left out of 51 total cards. 3rd card is red. There are 24 red cards left out of 50 total cards. Obviously, you can multiply and you can get those answers. C, you get no spades. Page, insert new page after this one. Okay. You get no spades. So, my first card is not a spade. And my second card is not a spade. And my 3rd card is not a spade. So, the probability of not a spade, just like not a heart, 39 over 52. Times the probability of not a spade, 38 over 51. Times, that's a lovely 8 by the way. Times probability of not a spade is 37 over 50. Okay, easy. You can multiply, you can get those answers. You have at least one ace. Okay, what does at least one ace mean? It means this. I've got 3 cards. I could have an ace and not an ace and not an ace. Or I could have not an ace and not an ace. Or I could have not an ace and not an ace and an ace. Or I could have an ace and not an ace. Or I could have an ace and not an ace and an ace. Or I could have not an ace and an ace and an ace. Or I could have an ace and an ace, and those would all be at least one ace. And I could figure out all of those and add them together because or means add. Or we could say at least one is the complement of none. So what I'm going to do is I'm going to find the probability of not an ace and not an ace and not an ace. And that's going to be none. I've got no aces. And I'm going to take that value and I'm going to subtract it from 1. So, not an ace is going to be 48 out of 52 times. Not an ace now. There are 47 not an aces out of 51. Oh, that's beeping, and we're almost done here. So we're just going to keep finishing this up. Times. Not an ace. There are 46 out of 50. So I take these values and I multiply them together. I get my result and I subtract it from 1 because I want the complement. And that would give me, and your final answer, by the way, Regis, on that one happens to be 0.2174. If you like fractions, however, your value would be 28,824 over 132,600. Woo!